Hello everyone, I'm glad to share my work on exploring the opportunity of augmented reality in supporting older adults to explore and learn smartphone applications. Nowadays, digital technologies evolve quickly. Many services are transforming online. While offering the convenience, it challenges people who do not grow up with the recent technologies. Although more and more people own smartphones, many older population want to use smartphone in a traditional feature phone way and do not use extended functions. Researchers have been exploring the reason and found that actually they're motivated to learn due to factors like perceived usefulness, social influence. However, they do not have effective support resources catering to their needs. They desire flexible and independent support approach to help them learn. AR has demonstrated the potential to enhance user experience and learning outcomes. It provides key features including interactive surface and extended video cues to engage and encourage people to learn. Existing literature has explored AR's opportunity for education. However, few consider older adults. While researchers started leveraging AR for older adults for prevention and wellness training, older adults expressed their acceptance of AR and found AR systems encouraging. This highlights an opportunity to leverage AR to support older adults in their learning process. Therefore, we raise the following research questions. RQ1. How could AR be potentially leveraged to support older adults in exploring and learning smartphone apps independently? RQ2. How might older adults want to interact with AR when exploring and learning smartphone apps? To address our RQs, we conducted a two-phase study. Phase 1, a workshop on investigating what challenges older adults face most when learning smartphones, and where AR can be applied to offer support. Phase 2, a technology pro-based participant design session to brainstorm and develop an innovative AR support tool collaboratively. For Phase 1, we first introduced AR to participants by presenting the video and letting them try the Blazing Flower demo. Then we asked them to show the challenges when learning smartphone apps. Finally, we had a brainstorm session what are the possible solutions to use AR solving their challenges. The insights gleaned from Phase 1 directly informed and shaped the design of the probe in Phase 2. In Phase 2, we first let them experience the AR tutorial to get an overview of AR interactions. Then we let them explore smartphone apps and showed our prototype when they encountered the corresponding problems. Finally, we held co-design sessions with each participant to draw their final ideas. We got the 4 key challenges participants face and the simple solution strategies from Phase 1. Then we designed the 6 type probes according to the design considerations. For small tests, we largely set the phone for terminology and the ambiguous feature we display using text or animation. For low confidence, we provide a virtual child space in 2 spatial locations and accompanying assistant. Our key insights lies in 3 aspects: possibilities of AR learning approaches, older adults' AR interaction preferences, and their concerns. Through the co-design sessions for possibilities of AR in supporting older adults to learn smartphone apps, we envision that AR can reduce older adults' physical burden, cognitive burden, facilitate exploratory learning, and bridge their knowledge gap. For reducing physical burden, AR can provide user-friendly operations for reduced fine motor skills and tactile sensitivity. Compared to touching on a physical smartphone screen, AR do not require older adults touch on a small screen precisely and do not need tactile recognition. Moreover, AR can enhance visual experiences for those with decreased visual acuity. The constraints of smartphone screens, particularly on smaller devices, present challenges for individuals with declined visual acuity. Participants' vision of employing AR to augment visual interactions includes illustrate 3D words in a brush style that seem to jump out from the display, depict a gesture-induced screen magnification to make the whole screen bigger, visualize a finger simulating a magnifying effect, reviews a multi-tier magnification process. For reducing cognitive burden, AR can facilitate smartphone app exploration for those with decreased working memory capacity. Our participants particularly mentioned that they feel burdensome during multi-app exploration. There are many tasks that can not only be achieved by a single app. For example, when they want to see the doctor, they may use search engines to search related information and shift to Map app to identify nearby hospitals, and finally make an appointment in the hospital's app. The need for multiple speaking and information recall from different apps led to fatigue and forgetfulness. Inspired by our AR probes extended screen, participants proposed using customized icons to streamline the task process to avoid being overwhelmed. In addition, they mentioned that comparing data across multiple apps and making proper decisions challenges. For instance, when choosing a hospital, factors like reputation and location are crucial. However, gathering this information often requires toggling between different apps, demanding a considerable cognitive load for memorization and decision making. Participants mentioned leveraging AR to create a decision board to combine all information together from different apps. Besides decision-making scenario, another approach is to compare similar items among apps. Participants suggested enabling them to open multi-windows like computer. Furthermore, AR can enhance focus for older adults who experience a decline in attentional resources. Participants frequently expressed frustration with the interruptions during their app exploration, citing disturbance like pop-up ads, app notifications, incoming calls, drawing inspiration from our AR demos, which showcase the extended screens and floating tests. Many participants propose a continual display of their current tasks and chosen app, helping them stay focused. In our probes, we demonstrate that AR may establish a digital sandbox for older adults to explore app functions safely. Participants further raise detailed designs. First, they want AR can record their exploration map. For example, they can use it to save different states when they face uncertainty while navigating to save their progress. If they get lost, they can enable states to be recovered and come back to the right step. In addition, participants mentioned that they could adopt a more methodical exploration strategy, avoid repetitive actions, and fostering more efficient learning using this method. Another design is that they want AR to mitigate their navigation uncertainties by providing a preview of the next screen of the app. It can help build a reassuring environment and reduce their anxiety. An accurate point among participants is that feel nervous and afraid of making mistakes in the confirmation stage, as it often marks the point of no return, for example, when confirming the payment. Participants suggest that leveraging AR to generate a confirmation list to allow for a quick and confident review. Additionally, participants raise real-world analogies linking digital payments to physical transforming money makes the digital experience more tangible and relatable. In this way, participants feel more sure that what they are doing and are easier to confirm the information compared to a long text with terminologies. Furthermore, AR can help bridge knowledge gap. For terminologies, our AR demonstration proposed clear and short textual explanations alongside unfamiliar terms. Participants favored a concept text over lengthy descriptions. While text was essential, participants also appreciated other mediums like videos and want more spatial effects which are interesting. They raise ideas of words coming to life and imagined complete immersion in a smartphone world. And some participants saw AR as a dynamic learning tool, superior to lessons from younger relatives. For small features, often symbolized by small icons, tend to be overlooked by older adults. To address this, our demo showcased methods like highlighting these features with both text and animated cues. While text was favored for its clarity, the timing of these feature pop-ups was crucial to avoid distractions. Interestingly, participants reflect that animations may not be a good choice because they need more time to comprehend what the animation referred to. We then investigate interaction preferences of older adults in AR learning. We enabled participants to experience the 7 interaction modalities in AR: touch, virtual pointer, pinch and move, pinch and drag, pinch and rotate, eye gaze, and voice. Among the 7 interactions in AR, older adults find touch and eye gaze are most intuitive and preferred. Voice interaction in this scenario is tedious. They also reported the challenges with virtual pointers and pinch gestures. We then summarize key points to improve AR learning. First, AR interaction should be close to the original interaction scenario. That is to say, the design of AR interaction should be similar to the familiar smartphone gestures. Second, voice interaction in this scenario should be as complementary instead of primary one, since it is too tedious to use voice to conduct each operation. Third, the design should consider error tolerance and psychological comfort. Precision in AR proved to be a challenge for many older participants. They preferred having a broader, more encompassing interaction followed by refinement. Interestingly, this was not purely about operational efficiency. It catered to their psychological comfort, offering a sense of achievement. Moreover, AR interactions should involve tangible surfaces that are anchored in the physical world. Participants' feedback underscored the need to bridge the tangible and the digital in AR interfaces, for instance, books, tables, and walls as tangible anchors. Last but not least, AR interactions for adults should consider spatial orientations that promote better posture and health. The inherent spatial adaptability of AR offers a diverse array of content positions, each with distinct health and engagement implications. Our findings indicate a strong preference among older adults for horizontal AR content placement, favoring the left or right for its immediate accessibility. Interestingly, vertical top-placed layouts carried potential health outcomes. Encouraging users to periodically elevate their gaze might counteract the downward smartphone posture, offering relief against the potential neck strain. As a conclusion, we show that AR has great potentials in supporting older adults in learning smartphone apps effectively, particularly for multi-app exploration. It is important to design intuitive, accessible AR interactions for older users, including involving tangible surfaces in daily lives, offering psychological comfort, and enhancing physical health. We also discussed key points to improve AR supporting tools adoption among older adults. The portability and weight of AR devices emerged as significant concerns, while participants were keen on leveraging AR across diverse contexts, including indoors and outdoors. The current device physically and usability impedance ubiquitous use. Moreover, the price of the device seemed unjustifiable if its primary use case was just aiding smartphone interactions. While participants expressed a preference for joint exploration, it opens other avenues for co-learning in AR environments, either for the social interaction between the helper and the older adults, or among older adults themselves. Integrating AR with gamified experiences, perhaps even serious game to boost your cognitive functions, could serve dual purpose, aiding smartphone exploration and fostering cognitive enhancement. Last, I sincerely thanks for all my collaborators and friends, as well as all the participants and staff in the community center. That's all. Thank you for listening.